Factorization using identities. In the previous exercises, we have done the factorization by using the identities, the first two identities. Now, let us use the third identity. If the expression has a form that fits the right hand side of one of the identities, then the expression corresponding to the left hand side of the identity gives the desired factorization. If the expression which is given in the sum, that is in the form of the right hand side of the equation in the identity, then it will fit the results for the left hand side. Let us do one example, you can understand. Factorize 49p square minus 36. See, 49 also a square number, p already square, p square, minus 36 is a square number. Okay, so solution for this, there are two terms, there are two terms are given, so these expression will not fit for the first two identities, and both the numbers are the squares. That is the second condition, and the second is in the negative integer. The second term is in negative, so the expression is of the form of a square minus b square. That fits the identity number 3. So we can use the identity number 3 for this given expression. So 49p square minus 36 can be written as 7p to the whole square minus 6 to the whole square. So we can rewrite it as 7p minus 6 multiplied by 7p plus 6. That is the required factorization. Let us move to the next slide. For factorizing an algebraic expression of the type x square plus px plus q, we find two factors a and b of q. So q will be factorized into a and b. In this given expression, there are all you can find the unlike terms. So q can be factorized into a and b, that is the constant term, such that a multiplied by b equal q and a plus b equal p. So they should be in this form. One should be in the product of two constants, another will be the summation of two constant values. Then the expression becomes x square plus a plus b multiplied by x plus ab. That is x square plus a multiplied by x plus b multiplied by x plus a multiplied by b. So in the next third step, x will be the common factor for the first two terms. So we can rewrite as x plus a, plus in the last two terms b will be the common factor, and inside the bracket we can write x plus a. Now in the third step, you can find that x plus a is a common factor and x plus b is the x is the non-common factor in the first term and b is the non-common factor in the second term. So we can rewrite as x plus a multiplied by x plus b. You can understand this concept using this example. The example is y square minus 7y plus 12. The solution is, we note 12 is the product of 3 into 4 and 7 is the sum of 3 plus 4. So they are in the form of identity number 4. So y square minus 7y plus 12 can be written as y square minus 3y minus 4y plus 12. So in the next step, we can rewrite it as y multiplied by y minus 3 minus 4 multiplied by y minus 3. Look at the first two terms, y square minus 3y, the common factor is y. So y multiplied by y minus 3 minus in the last two terms 4 will be the common factor for 4y and 12. So 4 multiplied by y minus 3. So y minus 3 is the common factor for both the terms. So we can rewrite it as y minus 3 multiplied by y minus 4. Note this time we did not compare the expressions with that in identity 4. So this time we did not compare this with the identity number 4 to identify which is A and which is B. So after sufficient practice, if you keep on practicing these kind of sums, you may not need to compare the given expressions for their factorization. So no need to compare the given expressions with the expressions in the identities. Instead, you can proceed directly as we did above. Let us move to the next exercise. So in exercise number 14.2, page number 224, we are in subdivision number 4, factorize. In that subdivision, the first one is a to the power 4 minus b to the power 4. The solution for this is, we note that a to the power 4 can be written as a square to the whole square, and b to the power 4 can be written as b square to the whole square. Thus the given expression fits the identity number 3. So we can rewrite it as, therefore a to the power 4 minus b to the power 4 equal a square to the whole square minus b square to the whole square. So the solution will be a square minus b square multiplied by a square plus b square by using the identity number 3. Let us move to the next exercise. P to the power 4 minus 81. The solution. So in the solution, we note that p to the power 4 can be written as p square to the whole square, and 81 can be written as 9 square. By using the identity number 3, we can rewrite it as p to the power 4 minus 81 can be written as p square to the whole square minus 9 square. So by using identity 3, we can write the solution as p square minus 9 multiplied by p square plus 9. The subdivision number 3 is your homework. Let us move to the fourth one. Okay, x to the power 4 minus x minus 2 to the x to the power 4 minus x minus z to the whole power 4. Okay, so the solution for this given expression is, x to the power 4 can be written as x square to the whole square, x minus z to the power 4 can be written as x minus z to the whole square, and write the curly square bracket to the whole square, x minus z square to the whole square, x minus z inside the bracket square, then make a square bracket to make the whole square of this expression. So the expression fits the identity number 3. So x to the power 4 minus x minus z to the whole power 4 can be written as x square to the whole square minus, open with the square bracket, and inside the bracket x minus z to the square to the whole square. So we rewrite this expression as, using the identity number 3, x square minus half x minus z to the whole square multiplied by, open the square bracket, x square plus x minus z to the whole square, close the bracket. We can further expand using identity 1 and 2. So they are in the form of using identity 1 and 2. So we can further expand. Let us move to the next slide. Okay, see here. The next step will be x square minus x square minus z square to the whole square, that is in the form of a minus b to the whole square. So by using identity number 2, we can rewrite it as x square minus 2xz plus z square multiplied by x square plus x square minus z square to the whole square, again can be written as, expanded as x square minus 2xz plus z square. So when we simplify this in the next step, we can rewrite it as x square. When you open this bracket, so all the symbols of these each and every term will change. So minus x square plus 2xz minus z square. The next factor, x square plus x square minus 2xz plus z square. When you simplify this x square and x square will go off. The remaining will be 2xz minus z square in the first factor. In the second factor, this x square plus x square will become 2x square minus 2xz plus z square. This is the required solution for the given expression. Fifth will be your homework. Let us move to the fifth subdivision number. Factorize the following expressions. The first one is p square plus 6p plus 8. The solution for this is, we note that 8 is the product of 2 multiplied by 4, and the sum of 2 and 6 is, the sum of 2 plus 4 equal 6. We know this. So we can rewrite the given expression as p square plus 6p plus 8 equivalent to p square plus 2p plus 4p plus 2 multiplied by 4. So here in the first two terms, p will be the common factor. P is the common factor and the two non-common factors are p plus 2 in the first two terms. The next two terms, 4 will be the common factor and the non-common factors in the third and fourth term are p and 2. So 4 multiplied by p plus 2. Again in this step you can see that p plus 2 is the common factor. So write p plus 2 as common factor multiplied by p plus 4 using identity number 4. Let us move to the next exercise. Next, second one is q square minus 10q plus 21. The solution, we note that 21 is the product of 3 and 7. 3 times of 7 is 21 and 10 is the sum 3 plus, when you add 3 with 7 you will get 10. So we can conclude that this will fit for the identity number 4. So first we have to rewrite the given expression as q square minus 10q plus 21. This can be written as q square and the middle term will become minus 3q minus 7q plus 21. So you have to change the middle term. Okay, then next, equivalent to, in the first two terms q will be the common factor and the non-common factors are q minus 3. Minus 7 will be the common factor for the last two terms, third and fourth term, and the non-common factors are q minus 3. Again in the next step, q minus 3 is the common factor and the multiplied by q minus 7. Q is the non-common factor for the first term and 7 will be the non-common factor for the next term. So q minus 7. By using identity number 4, we can write this as q minus 3 multiplied by q minus 7. The third will be your homework. So in these kind of sums, the second term, the middle term will be very important. Okay, so if you want to check the middle term, see, the middle term is, it does not have any variables which is from the first term and the second term. So we have to factorize in this way by using the identity number. For that you have to concentrate. So the middle term, the observation of middle term is very important to doing these kind of sums. Let us move to the next part. Explanation of division of algebraic expressions. So how we can divide the expressions. Till now we learned only about the factorizations. Now we are going to divide the algebraic expressions. We recall that division is the inverse operation of multiplication. The 7 multiplied by 8 can be written as 56. That gives 56 divided by 8 equals 7 or 56 divided by 7 equal 8. So we will recall this. We know that the inverse operation of multiplication is division. Division is the inverse operation of multiplication. So we may similarly follow the division of algebraic expression. So we follow the same method, same application for dividing the algebraic expressions. Here are the examples for various division methods of the expressions. See, first one is division of a monomial by another monomial. 6x cube division 2x. Okay, so we have to divide 6x cube by 2x. So first we will factorize. 6x cube can be factorized into 3 multiplied by 2 multiplied by x multiplied by x multiplied by x. Then 2x can be factorized as 2 multiplied by x. 6x cube division 2x can be written as 2x multiplied by 3x square. See here, 2x is the common factor for the numerator and the denominator. So 2x I have written here separately. The remaining factors are 3 and 2x's are remaining here. 3x square. So we can strike off 2x and the solution will be 3x square. Next one is division of polynomial by monomial. So one polynomial is given. So you have to divide the polynomial by monomial. So the given expression is 4y cube plus 5y square plus 6y, and it can be factorized as 4 can be factorized as 2 multiplied by 2 and y cube can be factorized as y multiplied by y multiplied by y, plus 5y square can be factorized as 5 multiplied by y multiplied by y, plus 6y can be factorized as 6 multiplied by y. Okay, so it should be divided by 2y. So we have to take 2y as the common factor. Look at the first term. So we can take 2y as common, multiplied by the remaining factors are 2y square, plus look at the middle term. You don't have any 2. You don't have the factor of 2. So what we have to do in those cases, we have to write the odd number. 5 can be written as 5 by 2 multiplied by 2. If you solve 5 by 2 multiplied by 2, you will get 5. So in this way we have to write to get a common factor. So 2y will be the common for the second middle term, and 5, the remaining are 5y divided by 2, plus in the third term 2y is common, multiplied by 3. Okay, next take 2y as common factor, and the non-common factors inside the bracket are 2y square plus 5y by 2 plus 3 divided by 2y. You can strike off 2y. The solution will be 2y square plus 5y by 2 plus 3. Let us go to the exercises. We are in page number 227, exercise number 14.3. Okay, carry out the following divisions. The first subdivision, number 1, 28x to the power 4 division 56x. 28x to the power 4 can be factorized as 2 multiplied by 2 multiplied by 7 multiplied by x multiplied by x multiplied by x multiplied by x. So this is the way you can factorize. Okay, then in deducible form. Next, 56x can be factorized as 2 multiplied by 2 multiplied by 2 multiplied by 7 multiplied by x. So now we have to divide that. 28x to the power 4 divided by 56x can be written as equivalent to 2 in the numerator. Write all the factors you found here, and the denominator write all the factors you found here. Then when you strike off all this, 2 will be, we can strike off the 2, and again 2, we can strike off the 7, you can strike off the 6. The remaining things are x cube will be in the numerator and 2 will be in the denominator. When you write down in your notebook, you can easily understand. Let us move to the next exercise. Minus 36y cube division 9y square. Minus 36y cube can be written as minus 4 multiplied by 9 multiplied by y multiplied by y multiplied by y. 9 can be written as 3 multiplied by 3. 9y square can be written as 3 multiplied by 3 multiplied by y multiplied by y. The next step, minus 36y cube division 9y square can be written as minus 4 multiplied by 3 multiplied by 3 multiplied by y multiplied by y multiplied by y divided by 3 multiplied by 3 multiplied by y multiplied by y. Okay, now you can strike off 3 with the 3, and again you can strike off another 3 with the 3. You can strike off this y and another y. The remaining things are, remaining factors are minus 4y. This will be the solution for the second one. Let us move to the next one. Number 3 and 5 are your homework. Let us do to the fourth one. 3 and 5 are your homework. Let us do the fourth one. 34x cube y cube z cube division 51x y square z cube. So 34x cube y cube z cube can be factorized as 2 multiplied by 17 multiplied by x into x into x multiplied by y into y into y multiplied by z into z into z. 51x y square z cube can be factorized as 3 multiplied by 17 x multiplied by y multiplied by y multiplied by z into z into z. So when you divide that, 34x cube y cube z cube division 51xy square z cube, we can rewrite it as 2 multiplied by 17 multiplied by x into x into x multiplied by y into y into y multiplied by z into z into z divided by 3 multiplied by 17 multiplied by x multiplied by y into y multiplied by z into z into z. So we can strike off this 17. First we can strike off 17, then we can strike off x, then we can strike off y, 2 y's, then we can strike off this 3 z's. So the remaining will be 2x square y divided by 3. Let us move to the next one. The next one is divide the given polynomial by the given monomial. What is the polynomial? 5x square minus 6x division 3x. First we have to factorize 5x square minus 6x. 5x square can be factorized as 5 multiplied by x minus 6x can be factorized as 2 multiplied by 3 multiplied by x. So we can rewrite it as see, you cannot find the common factor here. You cannot find the common constant value here. So there is the division is 3x. So we have to get a 3x. So what we have to do in this kind of things? So we have to rewrite the first term as 3 multiplied by 5 by 3 multiplied by x minus 2 multiplied by 3 multiplied by x. Now we can take 3x as the common factor. When you take 3x as common factor and the non-common factor in the first term is 5 by 3 into x minus 2. Okay, then we can do the division equal 3x multiplied by 5 by 3x minus 2 divided by 3x. We can strike off 3x. The solution will be 5 by 3x minus 2. Let us move to the next exercise. 3y to the power 8 minus 4y to the power 6 plus 5y to the power 4 division y to the power 4. 3y to the power 8 minus 4y to the power 6 plus 5y to the power 4. First we have to factorize this. So what is the factors of 3y to the power 8? 3 multiplied by y to the power 4 multiplied by y to the power 4. Why I have written here y to the power 4? Because we are going to divide with y to the power 4 minus 4y to the power 4 multiplied by y square plus 5 y to the power 4. Now we'll take the common term. Y to the power 4 is common term. The non-common factors are y to the power 4 is the common factor and the non-common factors are 3y to the power 4 minus 4y square plus 5 divided by y to the power 4. Strike off this y to the power 4, you will get the solution 3y to the power 4 minus 4y square plus 5. Let us move to the third one. Third one is 8 multiplied by x cube y square z square plus x square y cube z square plus x square y square z cube divide by 4x square y square z square. So here you can find that we need x square y square z square as the common factor for all these three terms. So we have here, so 8 can be factorized as 2 multiplied by 4. X cube y square z square can be factorized as x square into x y square z square. Now we got the common factors x square y square z square plus in the second term x square y square z square, x square y square multiplied by y cube can be written as y square multiplied by y multiplied by z square plus the next term, the last term, x square multiplied by y square multiplied by z square multiplied by z, because this is z cube. Okay, so we got the common factors x square y square z square for all the three term. So we can rewrite it as 2 multiplied by 4 multiplied by x square y square z square. Inside the bracket write the non-common factors x plus y plus z divide by 4x square y square z square. So what we will get, strike off this 4 and strike off x square y square z square from the numerator to the denominator. The solution will be 2 multiplied by x plus y plus z. Fourth and fifth are your homework. And complete your homework and complete on time. Don't waste your time. And I have given the worksheet in the last week that you will take 1 week of time to complete that worksheet and complete it, update everything students. We'll continue in the next class. Goodbye boys.